Algebra 1, lab number 7. We are looking at finding the line of best fit when we create a scatter plot on our graphing calculator. So I am right before lesson 71 in the Algebra 1 textbook, and it says a graphing calculator is often the easiest and most accurate method for making a scatter plot from a data set, and then finding the equation of the line of best fit. Oftentimes when we do scatter plots by hand, we end up with line of best fits that are good, but not exact. So our calculator does quite a bit to make sure that your line of best fit is accurate. So our data says the following table gives the total number Y in billions of movie admissions for X years after 1993. And we have a table that gives us years 1 through 10. So those are the amount of years after 1993. And our admissions, Y, as numbers like 1.29, 1.26. And remember, those are in billions of movie admissions. Just like we've created our box and whisker plot, we need to enter this data into our editor so that we can find a line of best fit and predict some things about the future. So let's go to our stat button here, just like we did for the box and whisker plot, so that we can, number one, edit our data. Remember, clear out any old data that you might have in here by going up to the header on your graph, on your table, pressing clear, and then it will clear out anything that you might have. So let's plug in L1 our X values, which are our years. So we just have our simple 1, enter 2, enter 3, 4, 5, 6, 7, 8, oops, should just be an 8, not an 88, 9, and lastly 10. So those are all the years after 1993. And now it's really important to make sure that we are actually entering the data correctly with the corresponding year into L2. So go over to your L2 by pressing the right button. And in L2, year 1, so the first year after 1993, has 1.29 as the admission amount in billions. Year number 2 has 1.26. Year number 3, 1.34. Year number 4 is 1.39. Be very careful with these, make sure you're plugging them in correctly. Our next year is 1.48, so that goes with year number 5. Year number 6 is 1.47. And then year number 7 is 1.42. Year number 8, 1.49. Year number 9, 1.63. And lastly, year number 10, 1.57. All right, so once you have all of that data entered in, just quickly scan it to make sure it looks like it's all correct. You can go through and check it point by point. Just make sure when you're doing a quick scan that you haven't added extra numbers that really shouldn't be there. So once we have our data in, we're going to look at one of our plots. Just like we did a box and whisker plot, we're going to go to stat plot. So do second y equals and go into that number 1 and turn it on just like we did before. Good thing to note, once you're done using these plots, turn them off for the next person. Maybe it's you, maybe it's a classmate. Turn off the stat plot so they don't end up getting errors in here. And then next, once you've turned it on, go to your type. And we have lots of different options here, but the first one is actually the correct one. It shows a scatter plot. Press enter. And then we have an X list and a Y list. If you did like me and put in your X values, your years into L1, you should be good there, and Y list is L2. Okay, so once you have that all correct and it looks like this, we can now view this by doing our regular zoom and then zoom stat number 9. All right, so we have our graph here. And we can see the scatter plot. It looks like a positive correlation since it has kind of a positive slope to it if we were to put a line of best fit through here. And we need to find that line of best fit. So the first thing that we're going to do is actually go back to our Stat button and go over to the Calc menu so that we have lots of options here. And what we want is the linear regression line ax plus b. That looks very similar to our equation y equals mx plus b, and it actually represents quite a bit the same. So that a represents your slope and b represents your y-intercept. So click on number 4 for linear regression ax plus b. And just check a couple things here. For X list, it should say L1. Y list, it says L2. Just so you know, if those are incorrect, you can actually change them by doing second and then stat. That will give you a list of different areas that you could have put your information. For mine, I would just press 1 for L1 to make sure that that list said L1. You can change your L2 if it's not correct as far as where you put your information. Okay, so continuing on, don't worry about that frequency list. We don't need to put anything right there, but we do need to store our equation somewhere. Otherwise, it will just show up in a calculator page and you'll have to plug it into your y equals editor. We actually want to put it into the y equals editor. So what you're going to do is press vars, which just is basically variables. Okay, go over to the y vars. Okay, press number 1 for function. I know this is lots of steps, but hang with me. And then we want it in y1. That's basically saying put this equation into y1 in our y equals editor. So press enter on number 1, and it will say that it's storing the regular equation in y1. Go down to calculate and press enter. And the first thing that it'll show you is this page here. You might not have that r squared or r, that's fine. That's actually for some correlation coefficients that you'll get to later in math. But what you care about right now is the a and b values. What this is saying is that your a value, your slope, is 0.036 and your y-intercept is 1.236. What's nice about storing our equation in that y equals is that I can graph it right away by just pressing graph. If we didn't store it somewhere, we would have to then plug that information into our y equals editor. So we now have our line of best fit through this information so that we can make some predictions. Like in our book, it wants us to predict year 11 after 1993, so year 2004. Well, what we would normally do is say we could trace it or we could use one of the other functions in our calculator, but unfortunately our window is not big enough right now. It only goes up to year 10. So we have to change our window to see more into the future to actually predict with this line. So go to the window button. Your x minimum is fine where it is, but just change your x maximum to 11 so that we can actually see year 11 when we do this. Your y minimum and y maximum are just fine where they are. And then go ahead. You can graph it again if you would like to, or you can go straight into tracing this specific value that I want. You could press just regular trace, but your calculator has a function to a specific number for a trace. And that happens when you do second trace. So you're going into the calculator function here, and we want a specific value to trace. So number 1 value. This allows you to plug in an x value into right here where it's blinking. And since we want year 11, I'm going to press that x is 11 and press enter, and it will trace it for you exactly. And it says if x is 11, then y is 1.632. What this is saying is that based on our line of best fit, our prediction for year 11 is 1.632 billion movie admissions. So we can predict a lot of different things by using this line. So let's say we wanted a lot further into the future. Let's say year 20. Well, we would go back to our window, make sure that we saw enough of the information into year 20, and then we could use our calculator function. So second calc, press 1 for value, and then say I want year 20. So we'll wait for it to calculate and then press 20. And we will see that in year 20, we would expect, if it continued with this trend, 1.956 billion movie admissions. So this is how we would use scatter plots and lines of best fit on our calculator to predict different values into the future. Once again, this is Algebra 1 lab number 7.